Welcome back to Math for Technology. This is a video on section 5.5, Applications of Trigonometry. In this section we have many formulas that we're going to talk about. I tried to put them all at the top of the paper here so you could just scroll through them. Not that quickly though. So we have arc length and area of a sector, which we've actually used before in chapter 3, and this is the radian version of those. We have rotational motion, which deals with velocity and time. We have velocity, which has 3 different versions. On the first one, that is S, that S stands for arc length, so it's arc length divided by time. The next one is the actual other side of the formula for arc length, so that's with the angle and the radius divided by time. And then the third one, that symbol that might be new to you there is omega. It stands for angular velocity, and so it would be the angular velocity times the radius. So the one you choose will be the one that's depending on what information is given to you. With centripetal acceleration, we have 2 forms. We have velocity squared over radius, and then we have the angle squared. That angle again is in radians times the radius divided by the time squared. Again, that will be depending on what information is given. We have an angular distance, so if we're looking for a distance between 2 points, say on the Earth, because our Earth is not flat, we would need that formula to help us with that. The L's and the M's stand for longitude and latitude. We have angular velocity, which was up in the velocity formula, so there's that omega symbol again. To find it, we can take the angle in radians and divide it by time, or we can do the velocity from up above and divide it by the radius. The key here that we have to remember is angular velocity, which is the theta, over time. So angular velocity is measured in radians per time, so per minute per second. When you're using angular velocity, you have to make sure it's in that form before you can use it. Then we have angular acceleration, which works with the angular velocity at the end, or the final, minus the angular velocity at the beginning, or the original, divided by the time during that span. So we're going to do the same 4 equations, or 4 examples, and I'm going to try and explain them the best I can. A ball is spun in a horizontal circle 60 centimeters in radius at the rate of 1 revolution every 3 seconds. What is the ball's velocity and centripetal acceleration? So if I go ahead and focus on the velocity first, up above, remember we had 3 options. So I have 60 centimeters, so I have a radius, and it's moving at a rate of 1 revolution every 3 seconds. So a revolution every second, that is angular velocity, but it's not in the right form because it's not in radians. So we are going to use it, but we're going to convert it to radians, and then we'll multiply it by the radius. So we're going to use this omega, or angular velocity, times radius. So V equals angular velocity times the radius. So we know it's 1 revolution every 3 seconds. So there's this thing called dimensional analysis, and that's where you convert from one dimension or one unit to another unit. So I'm going to put an example, and I tend to write it as the form of a table. It just makes more sense for me. And what it does is it helps us relate what we know. So I know I have 1 revolution in 3 seconds. In order to use angular velocity, I have to put this in radians per time, and radians per second is fine. So I have to think back to chapter 3 and circles, and we know that 1 circle, or 1 revolution, has 2 pi radians. Now, to decide where you're going to put this, I'm going to put the 1 revolution here, because if I have something in the numerator and something in the denominator, it will cancel. So this way my revolutions goes away. My 1 revolution is equal to 2 pi radians. So 2 pi radians over 1 revolution is the same as multiplying by 1, because the top and the bottom are equal. But it allows me to convert out of revolutions and into radians, which is what angular velocity is. So this right here, I'm going to go ahead and shorten my line. Oh, I didn't mean to make it disappear though. Let's try that again. So 1 times 2 pi is 2 pi. 3 times 1 is 3. So this is 2 pi radians per 3 seconds. So now I'm in angular velocity. So that's this guy. So 2 pi times 3, or over 3, sorry. So now what I have to do is, that's my angular velocity. I need to multiply it by the radius. My radius is 60 centimeters. So I'm going to times this by 60 centimeters. And that's over 1 because there's no bottom unit. So I multiply straight across, just like I did here. Everything gets multiplied straight lines horizontally. So I'm going to go 2 pi times 60, which is 120 pi. 3 times 1, which is 3. 120 divided by 3 is 40. So it's 40 pi. Now I can go ahead and grab my calculator and do 40 times the pi symbol. And so I get my velocity, put my answer over here, my velocity is approximately 126. Now look at your units. They were distance of centimeters, and my time is in seconds. So it's 126 centimeters per second. So that's my velocity. Now this question has a second part. It's the centripetal acceleration. So if I look up to the centripetal acceleration, I can take my velocity, which I actually just found, square it, and divide it by the radius. So that seems to work. So my centripetal acceleration is going to be my velocity. Now for accuracy, I'm not going to use the 126. I'm going to go back and use the 40 pi because that's the most accurate. So I'm going to do 40 pi. Now that is centimeters per second, so centimeters and seconds. So I'm going to take that, I'm going to square it, and then I'm going to divide it by the radius of 60 centimeters. So 40 times pi, I'm going to go ahead and square it, and then I'm going to go ahead and divide by 60. So in my calculator I get 263 approximately. Now let's look at our units. I have a centimeter that I've squared. Down here I have a centimeter. So if I have a centimeter squared over a centimeter, the one on the bottom takes out one on the top, so I definitely only have a single centimeter left. I still have the unit of time. So my centripetal acceleration is 263 centimeters every second that it's accelerating, versus my velocity, actually I forgot I squared that right here, so that should be seconds squared, versus my velocity is 126 centimeters per second. So that's number 1. So let's go down and check out number 2. If Knoxville, Tennessee is at a latitude of 36 degrees north and a longitude of 83 degrees 55 minutes west, and Denver, Colorado is at a latitude of 39 degrees 44 minutes north and a longitude of 104 degrees 59 minutes west, the radius of the Earth is 3,960 miles. How far is it from Knoxville to Denver? So we're talking about 2 cities on the outside of the Earth. So we're going to need to be doing some angular distance, which was given up above. So hopefully you printed this out so you can see it all and not have to scroll back up and down like I am. So we're going to use this angular distance formula here. So we're going to start by just writing out what we know. We have cosine of d, which stands for distance. It's actually an angle, and we'll get to that. I'm going to do sine of L1, so that's my first latitude. It doesn't matter which one I start with. So I'm going to go and just start with 36 degrees because that was the first one given. I'm then going to multiply that by sine of the second one, which the second latitude is 39 degrees 44 minutes, plus cosine of the same first latitude times the cosine of the same second latitude times the cosine, and here's where our longitudes come in. We subtract them, and you have to do it in the same order that you placed these. So since I put the 36 degrees first, I'm going to take the longitude of that one first. So that's 83 degrees 55 minutes minus 104 degrees 59 minutes. So this is what I'm going to be plugging in. Now when you go to plug it in your calculator, there are 60 minutes in 1 degree. So these numbers, this 44 that's here and here, those are both just going to be divided by 60 to turn them into a decimal. The 55 will be divided by 60, and the 59 will be divided by 60. So we're going to turn these all into decimals. So the 39, so let's go ahead and do that first. 44 divided by 60. So this is going to be 39.73 repeating. And same here. The 83.55, so we're going to go 55 divided by 60. So this is 83.916 repeating. Then we have the 104, so we're going to go 59 divided by 60. So this one is 104.983 repeating. Okay, so now we're going to plug this in. Hopefully you have a calculator that's doing your trig functions for you. So we're going to go sine of 36. So depending on your trig function, you might have to put sine in first or 36 in first. We're going to multiply that by the sine of the 39. And I just put a few 3's in. I don't put all of them in. Now we're going to add cosine of 36, which is being multiplied by cosine of 39.73. Let's put in a few of those. Times the cosine of 83.91, put in a few 6's, minus 104.98, put in a few 3's, and this calculator that I'm using did not work. I love that when that happens. Hopefully yours did better. You should get, oh wait, nope, it didn't work because I got a number that was way too big. You should get a decimal. Okay, so I've re-inputted it in a different calculator, and I got cosine of D is approximately 0.956. So figure out your calculator to make sure you can get that. Now, since I'm looking for D, right now I've got cosine of D is that. I got to find out what D is. D is an angle. It's the angle created between those two cities. So I have to do the inverse. So cosine to the -1 of 0.956. And when I get that, I get D is approximately 17 degrees. Now, that's not what we're looking for yet. That is just the angle that is created between those two cities. So I actually want the distance that's created between those two cities. Think of the world like a ball. And so the point from city to city would be like doing an arc length. So I'm going to go use the arc length formula now. Arc length formula is S equals R theta. R is the radius of the Earth, which is 3,960. Now my theta is in degrees, and in this formula I have to have it in radians. So I'm going to take it into my other formula. And so remember the formula was D over 180 equals R over pi. So I'm going to put the 17 degrees in here and do the math from last chapter. So I get approximately 0.2967 for my radians. I'm going to multiply that by 3,960 radius, right, which is in miles. And I end up that those two cities, the arc length is 1,175 miles apart. Okay, now I'm going to go ahead and stop this video. I have to go teach a class. I will do the other two problems in a second video and upload them.